So before we dive into explaining the data structure and more abstract concepts that geometry nodes depend on, I want to start out by showing you the very basics that you need to know to get started using geometry nodes right away. That means mostly just navigating the UI and learning the very fundamentals that geometry nodes are based on. To get most of the functionality that you need into one view, it's best to use the Geometry Nodes workspace. The workspace is equipped with a 3D viewport, a spreadsheet editor, an outliner and properties panel, and then, most importantly, the Geometry Node editor. To add a Geometry Node system on an object, you will first need to add a Geometry Nodes modifier. You can add it just like any other modifier from the list in the Modifier tab, or you can click the New button in the Node editor, which will automatically create a modifier for you. That modifier itself is then just a container for a node tree you can customize however you want using the node editor. With the data block picker, you can pick between different node trees that are available in your blend file. That way you can reuse the same Geometry Nodes modifier on several different objects. You can also stack multiple Geometry Nodes modifiers just the same way as you can stack any other modifier. A modifier just takes the geometry from the previous one as an input, modifies it somehow, and then passes it along to the next one as an output. That works the exact same way with geometry nodes as with any other modifier. Just now you are in precise control of what that modifier actually does exactly. The Geometry Nodes modifier is also where you will be able to see the different custom parameters that you can control the modifier with, just as you can any built-in modifier. And each instance where you use the node tree in a modifier has its own set of input parameters. The node tree that belongs to the currently active modifier will be displayed in the Geometry Node editor. Here you can control all of the operations that the Geometry Nodes modifier does on the geometry. Make sure that when you have multiple modifiers in the stack, the right one is selected before you can edit the node tree. When you create a new node tree, it comes with only two nodes that are connected to each other, the group input node and the group output node. The group input passes in the geometry of your object coming from the previous modifier, and the output passes it back out to the next one. So by default, a new node tree does simply nothing with the geometry. It just passes it along in the modifier stack. And so if I just cut this connection, you can see that the cube disappears, as now no geometry is passed to the outside anymore. But, of course, the cube still exists, as everything a modifier does is non-destructive. We can just bring it back by simply reconnecting the input geometry to the group output. Now, inside of the node tree, you can pass around the geometry of an object between the different nodes. And this is also how you can make custom modifications of the geometry using nodes. As a simple example, let's just add a transform node with the Shift-A menu to move the cube by a vector. Now, the cool thing here is that both the group input node and the transform node output their own geometry that we can use again in the node tree. So instead of just connecting one of them to the group output, I can also join the transformed cube and the untransformed one together and see them side by side in one geometry. In other words, the transform node does not actually alter the geometry from the group input. Instead, it creates its own copy of the data and provides the result of the transformation as its own output. And these two geometries can be used separately. You can still access both the transformed and the untransformed geometry and use it however you want inside of the node tree. This already shows one of the main strengths of the Geometry Node system over the modifier stack. You can easily branch off the geometry and have different operations in parallel, rather than operating on a single stack. The same, of course, is also true for any other node that has a geometry in and output, for example the join node. It also creates its own new geometry output that we can use just as well as any other geometry output in the node tree. You can see what data each geometry output contains by hovering over the socket. So here you see that the result of the join operation results in exactly double of the data from a single cube. I have shown before that you can use multiple geometry nodes modifiers in the stack. So let's just duplicate this one a couple of times. This way, the result of the previous one is piped through the same operation again and again. And because all of these modifiers share the same node tree that they are using, they're all controlled with the same nodes. So as I make changes to the parameters of this transform node, you can see how the changes propagate to every time that the cube is being duplicated, and it affects all of them at the same time. But actually, we are not only creating a single new cube with every step, each time we are creating a full copy of the input. So there are a couple of extra cubes that are hiding in plain sight. If I add another transform node into the mix, that reveals all of the additional copies of cubes that we have been creating. The number of cubes actually doubles with every modifier, and so the number rises exponentially. That gives us this cool fractal effect that we can control with just these two transform nodes. And there you go, that's already your first abstract art piece created with geometry nodes. And the input geometry can of course still be exchanged for anything else but the cube. We can, for example, also get a Suzanne in there. One interesting thing about the node trees that you reference in the geometry nodes modifier is that they are also regular node groups. That means that they can be nested as single nodes in other node trees. This way you can make full use of a procedural system and combine different custom geometry node operations in one bigger geometry nodes modifier. That also means that sharing geometry nodes modifiers works the same way as sharing node groups between different blend files and people. You can simply link or append the node tree from another file and reference it in your geometry nodes modifier. To benefit from this, we can give your node group custom inputs and outputs that are exposed to the outside. These node group inputs are also what is shown in the modifier interface in the properties panel. This is very powerful, as these parameters can be set differently each time that the node tree is used in another modifier or another node. These in and outputs work the same way as you would expect from the other node systems in Blender. You can adjust their settings in the Group tab of the Node Editor properties. So any geometry node's node group can be referenced in a geometry nodes modifier, and all of its in and outputs are exposed directly in the user interface. That makes the modifiers quite customizable and looks very similar to the built-in ones. And that way, you can make your own custom modifiers that you can share between projects and with others. I recommend you to play around a bit with the node groups that I'm providing in the files section and the nodes that I've been showing in this video. That's the thing with geometry nodes. Even with a relatively limited understanding of how exactly they work, it can be a lot of fun and very powerful to build something with them.